So like we just said, tangents to a circle. A tangent line to a circle is a line that crosses through a circle at exactly one point called the point of tangency. A couple of interesting properties and noteworthy things to remember when it comes to tangents for circles are up on the board here. Line L is tangent to circle A, and line L crosses through circle A at the point of tangency, called letter B. AB is what part of the circle? How would you call this? The distance from the center to the edge of the circle, the radius. What type of angle is formed between the radius and tangent line? I've labeled what type of angle? 90-degree or right angle. Radius of the circle is perpendicular to a tangent line. If it wasn't perpendicular, it wouldn't be a tangent line. It would either cross through not at all or twice. AB. And that red tangent line crossing through the circle at exactly one point, called letter B, the point of tangency. As I move the radius, I move the tangent line around the circle. Does that right angle between the green radius and red tangent line ever change from 90 degrees? No. Like I said, in order for a tangent line to cross through a circle exactly once, it's got to be perpendicular to the radius. If it was anything else, the tangent line would either cross through twice and not be a tangent line, or not cross through at all. Another important property here. We talked about inscribed angles. An inscribed angle is an angle within a circle. A circumscribed angle is something a little bit different. A circumscribed angle is an angle between two tangents to a circle. A circumscribed angle is an angle about a circle, between two tangents to a circle. Angle D is the inscribed, I'm sorry, I've been so used to saying inscribed angle. Angle D is the circumscribed angle because the two sides of angle D are the two tangents to the circle. AD and CD are two tangents to the same circle. The angle between those two tangents, called angle D, is now known as a circumscribed angle. Since AD and CD are two tangents, what do you know about angle A and angle C? They're both what measure? 90 degrees, using the same property from over here. Where these two tangent lines intersect the circle, it creates a 90-degree angle with the radius. Radius BC is perpendicular to the tangent line on bottom. Radius AB is perpendicular to the tangent line. Before I talk about what's important about a circumscribed angle, you guys remember what all four angles in a quadrilateral have to add up to? We know all three angles in a triangle have a total sum of 180. What the four angles in a quadrilateral? 60. Because I can divide a quadrilateral into two triangles. Since a triangle angle sum is 180, a quadrilateral angle sum is just 180 twice. Because I can cut a quadrilateral triangle. So all four angles in this figure have to add up to a total of 360. I already know that two of them need to be 90, where the two tangent lines touch the two radii. How much does that leave left over for angles B and D? If I've spent 180 out of a total of 360 for two angles, what does that leave left over for the other two? Say again? 180. 180. So angle D and angle B are what are called supplementary. have to add up to 180 degrees. So for example, if angle B is 135 degrees, what's left over for angle D? 40. Using more of the correct circle terminology, the circumscribed angle angle B is what type of angle? An angle where the vertex is at the center is known as a central angle.
Bethany Button, please report to the secondary office. Bethany Button, report to the secondary office.
Circumscribed angle and the central angle of a circle must always be supplementary. The reason being, the circumscribed angle is formed by two tangents. The two tangents to the circle take up a total of 180 degrees out of a total of 360, because there are two right angles. If I already spent 180 out of the 360 I have for all four angles, that leaves 180 always left over for the other two angles in this table. Central angle and the circumscribed angle must always add up to 180, and therefore are supplementary.